Hello, this is Ms. Hammonds. So because of the length of the PowerPoint and the notes, I'm going to try to keep each one of the teaching videos to 10 minutes. So you may have multiple videos to watch if you're not able to participate in the live lesson when we go over these notes. All right, so there is a really interesting video that introduces us to the concept of electric charges, specifically static electricity. But for time's sake, I'm just going to go ahead and move past this. We will actually go through that information in the live class. All right, so our standard is to investigate and explain that electrical currents can exert a force on each other. And then what does that mean, to exert a force? Well, to exert simply means to apply or to use. So like if I was to walk up to one of you and put my hands on you, the force that I could exert to you is to push you or repel you from me. Or I could pull you closer toward me and give you a hug, which is what I prefer to do. All right, we're going to go past this turn to your seat partner. I'm going to go ahead and get to the beginning of the notes. All right, so where it says, have you ever reached out to open a door and received a shock from the doorknob? And I have. Typically in the fall, when I'm wearing more sweaters, it seems like I get shocked more often when I go to open the door than when I just wear springtime lightly things that is not as heavy as a sweater. Well, in order to understand why this happens, you have to understand what the electrical charges are. All right. So now we're going to jump into the notes, which I have on my split screen. So because I initially taught this lesson and my video didn't record, a lot of the information is already created. So I'm just going to bold it so that it's easier for you to see. I can increase the font on here, Control++. All right, I don't have much time, so I need you to work thing. All right, so all matter is made up of very small particles. And these particles are called atoms. So over here on our notes, I'm just going to bold this portion for us. All right, and so atoms is what you should have written into the blank. Atoms are made up of even smaller particles called protons, neutrons, and electrons. And remember, when we first started talking about matter and we talked about atoms, we stated that the subatomic particles, and subatomic meaning that it's actually smaller than the atom itself, were protons, neutrons, and electrons. So do you guys remember where these subatomic particles were located for the atom? So for question 3, it says label the protons, neutrons, and electrons in the diagram below. All right, we'll go to the next slide. All right, so protons and neutrons actually make up the center of the atom, and we refer to that center as the nucleus. So here, where we have the blue and yellow items, that's where we're going to have our protons and neutrons. So you can just randomly select a color. However, as long as you know that protons and neutrons are located in the nucleus, you're well on your way. Excuse me. For the items that are green, that are circling around the nucleus, each one of these circles represents a different level or a cloud that the electrons are located on. So remember, we said that the first circle could hold only a maximum of 2. The second circle could hold a maximum of 8. And then the third circle could go up to 32, but it just depended on how many electrons were present in that particular atom or element. All right, so the green dots is what we would label as our electrons. And it just tells you that electrons are found on the outside of the nucleus. All right. So protons and electrons are charged particles, and the neutrons are not charged. So if you're looking at my diagram on the PowerPoint, It tells you that electrons have a negative charge, protons have a positive charge, and neutrons have no charge because they're neutral. So for your notes, for question 4, protons and electrons are charged particles, and neutrons are not. All right, we're going to move on. So a charge is a physical property. When we were first talking about matter, we talked about what chemical properties are and what physical properties are. And chemical properties are those properties that are associated with the production of a new product. So like when we talked about burning firewood, and then after the wood had completed its burn, it became ashes. Well, the ashes can't be turned back into wood, so that's a chemical change because we produce a new product. However, with a physical property, it's usually something that's associated with its appearance or possibly a state of matter. So it may go from a solid to a liquid to a gas. And it says an object can have a positive charge, a negative charge, or no charge at all associated with its physical property. So looking at number 5, the first blank is charge is a physical property that can be positive or negative. All right. Charged objects can exert a force that is a push or a pull on other charged objects. So if you've ever heard the term opposites attract, this is where that scenario would apply. So here where we have the little man pushing away, typically if they're repelling each other or pushing each other away, they have the same charge. But if they're being pulled closer together, then that's an attractive charge, and that typically occurs between objects that have opposite charges. So to complete number 6, charged objects exert a force that will either push or pull the charged objects. And I'm just going to go ahead and highlight that for you. All right, so again, if I'm moving too quickly, I apologize. I gave myself 10 minutes, and however far I can get in 10 minutes, that's how we're going to make it happen. All right, so moving on in the slide. Here is an example of those forces being exerted. So in a situation where you have two opposite charges, they're going to attract. But when you have two of the same charges, two positive or two negative, they're going to repel. So for our number 7, objects that have the same charge will repel. And then for number 8, objects that have opposite charges will attract. For number 9, you're asked to draw 3 pictures demonstrating how charges exert force on each other, and then label those charges and whether the forces are attracting or repelling. So in each one of these 3 boxes, typically what I would do is I would go to the PowerPoint and I would click on the image and then transport it into the Word document. But because it's one entire picture, it may not allow you to do that. So if your number 9 is not completed, that's okay. But if I were able to place these into the boxes, the first one, the minus and the plus, I would have in the first box, and I would make sure that I label that as attract. And then in the next box, I would have the 2 plus signs and make sure that I note that they repel. And then I would have the 2 minus signs and make sure that I note that they repel. All right. All right, so objects that have the same charge repel each other, and each object exerts a force on the other object. These forces push the objects apart. So here we have another example of those that are repelling or moving away from each other. We have 2 positive charged particles and 2 negatively charged particles. All right, so for number 10, let's go to the next slide. It's not matching up with my notes. But anyway, protons have a positive charge. That's just from our previous knowledge. While electrons have a negative charge, which is what we previously discussed. Why do electrons stay around the nucleus of the atom? So they're going to stay around the nucleus of the atom because they both have opposite charges. All right, so my timer went off just to remind me that I have been going over these notes for 10 minutes, and I did not want to make the videos extremely long. So I'm going to stop here at number 11. All right, so 11, why do electrons stay around the nucleus of the atom? And I wrote because they have opposite charges. So let me just elaborate on that before I end the video. So we stated that the nucleus has two particles or two subatomic particles, one that is positively charged, which is our protons, one that is negatively charged, which is our neutrons, or they have no charge at all, I should say. The electrons that are circling around the nucleus have a negative charge because electrons are negatively charged. So in a situation where we have a group of particles and we have more that are positively charged than those that are neutral or negative, then that entire substance or that entire object will have a positive charge. In a situation where we have a lot more negatively charged particles than we do positively charged, then the whole object will take on a negative charge. So because in most cases atoms have the same number of electrons as it has protons and neutrons, then the charge of the atom will typically be no charge at all because they're equal and they cancel each other out. But the purpose of answering the question, why do electrons stay around the nucleus, is because of the opposite attracting. You have that negatively charged electron circling around the positively charged nucleus, and so they're attracting to each other, and that's what helps hold them in their electron cloud. All right, so I hope that this video was helpful. I'm going to go ahead and scroll back up to the top so that you're able to see all of the questions that we've highlighted, and then you can continue the notes in the part 2 video. All right, bye.